Guys, this lesson is 7.4 Matrices and Systems of Equations. Today we're going to be looking at how we can use a matrix to solve a system of equations. In the past, we've solved a system by graphing, by substitution, and by elimination. So now we're going to look at how we can do that with matrices. First, some basics on matrices. A matrix is a rectangular arrangement of numbers. And let's highlight that. So that has columns and rows. So how this works is going across, just like in a movie theater, we have rows. So across, you move across the rows in a movie theater. Up and down is like columns of a building. And so those are your columns. So this matrix, we have a dimension or an order. So we call the order or the dimension, which is the size, row by column. So notice there are 3 rows. So we would write 3 by, and there's 2 columns. So it's a 3 by 2. Looking at a entry in the matrix, we could say the entry, if we call this matrix A, and we're looking at 3, 2, so that would be 3 rows and 2 columns, we would be looking at the entry -2. A square matrix has the same number of rows as columns. Let's highlight that. Example 1, you're supposed to find the order of the matrix and tell me if it's a square matrix. So it's not a square because it does not have the same number of rows as columns. And the order is rows go across 1, 2, 3. So it has 3 rows. And the columns 1, 2, 3, 4. It has 4 columns. So therefore, it's a 3 by 4. It wants us to list the element in this matrix. We're calling it matrix B, and we're looking for B2, 4. So 2 stands for the row, so you'll go down 1, 2, second row, and then 4 is over to the 4th column, and then you look for that number. So I'm going to switch that to a highlighter. And that would be this number right here. And so that entry is 6. So today the focus is solving a system of equations. So we see here we have a system of equations and it has 3 variables and 3 equations. The coefficients are the numbers in front of the variables. So A1 is a coefficient, B1 is a coefficient, and C1 is a coefficient. When we write a coefficient matrix, we use A1, B1, C1, the coefficients of the first equation. The second equation, A2, B2, C2, we have A2, B2, C2. And the third equation, we have A3, B3, C3, and A3, B3, C3 are the coefficients of the third equation. Now, an augmented matrix, which is what we'll be using today, is we use the coefficient matrix, A1, B1, C1, and then equals, and then whatever this number is represents your D1. So the first equation, we have A1, B1, C1, D1. When we write the augmented matrix, we use A1, the first coefficient, B1, the second coefficient, C1, the third coefficient, and then equals D1, whatever that constant term is. And you can see here, we set up the augmented matrix. So row echelon form of a matrix. That's going to be a matrix that looks in triangular form. So if you remember right here, we have a triangular form system. We have Z equals 3, so that's what Z is. We have one equation. So we have one equation in one variable. We have one equation in two variables. Y subtract z equals 4, and one equation in three variables, x, y, and z. This is called triangular form. If I were to write the augmented matrix, let's see what that looks like. So we have the first equation, and we're just taking the coefficients. So there's a 1 in front of the x, there's a -1 in front of the y, there's a 2 in front of the z, and it equals -3. All right, so there's our first equation. So now let's look at the second one. There's a 1 in front of the y. There's a -1 in front of the z, and it equals 4. And then the last equation, there's no x, there's no y, and there's one z, which equals 3. And if you notice, this system, and a lot of times you'll see a line here where the equal sign is, just so you know. Let's look at this pattern. So when we see this augmented matrix, do you notice that if we start in the upper left corner, we have ones going diagonally? This is what a row echelon form matrix looks like. And if we have a row echelon form matrix, we can figure out what x, y, and z are. We know that z is this 3. We know that we could take this equation, plug in z, find y, and take this equation, plug in y and z, and find what x equals. So what I'm going to do is take this row echelon form matrix, and I'm just going to go ahead, and since there was no x, I'm going to put in a 0 here. And since there was no x and no y, I'm going to put in zeros there. So what you can see is we have this diagonal of ones with zeros below it. What we're going to do in this next example is we're going to take a system of equations. We're going to interchange rows. We can multiply an entire row by a number, or we can add rows together and replace rows. We're going to do that to get the system in this form that you see right here, which is row echelon form. Because when it's in row echelon form, we know we can figure out what x, y, and z are in the system. So let's begin. So what we're going to do in example 2 is we're going to take the system of equations, which is 3x plus 2y plus equals 5, and so forth, and we are going to write it as an augmented matrix. And then as an augmented matrix, we're going to change that matrix to row echelon form. So how we do that, the augmented matrix is 3, 2, 1, 5, 1, -1, 1, 4, 1, 3, -2, and -3. So row echelon form means we want this diagonal to be all ones, and we want all of the numbers below it to be 0. So how we're going to start with that is we're going to start by trying to get this 3 to be a 1. So if we look right here, I want this 3 to be a 1. So do you see how the second row is already a 1? So what we can do is this stands for row 1. So here's row 1, and we're going to switch it with row 2. And here's row 2. So I'm going to stop the video and quickly switch those two rows. So you can see that I switched these two rows. And now what I'm going to do is I want to get this 3 right here to be a 0. So to make that a 0, you look at the matrix and you try to decide what can I do to make this turn to 0. So what if I took -3 and I multiplied it to row 1, and then I add it to row 2, and that's going to give me my new row 2. So let's try that. So -3 times row 1. That's going to give us -3. -3 times -1 is 3. -3 times 1 is -3. And -3 times 4 is -12. And row 2 is 3, 2, 1, 5. And when I add those two rows together, hey, look, I get a 0, which is going to go in for that 3 right there. I get a 3 plus 2 is 5. A -2 plus 1 is, or -3 plus 1 is -2. And a -12 plus 5 is -7. So now what I'm going to do is replace this row with this new row. So now if you look, here is my new row 2, see new row 2, and I put it here under my new row 2. So the next thing I want to do is I want this 1 down here to be a 0. So I have to try to figure out what can I do to make that 1 a 0. Well, what if I took the opposite of row 1, added it to row 3, and then that was my new row 3? I think that's going to work. So I'm going to take the opposite of row 1. I'm going to add it to row 3, and that's going to be my new row 3. So let's give it a try. So the opposite of row 1 would give me -1, +1, -1, -4. And row 3 is 1, 3, -2, -3. I'm going to add those two rows together. I get a 0, a 4, a -3, and a -7. So what I'm going to do now is stop the video. I'm going to take this row 3, here's the row 3, and I'm going to replace it with the new row 3. I'll do that now. So here's my matrix. You can see I took row 3 and I replaced it with the new row 3. And now what I want to do is I want this 5 to become a 1. And so in order for that 5 to become a 1, I'm going to take -1 and multiply it to row 3. That would give me a -4. And then I'm going to add that to row 2. And that's going to be my new row 2. So let's go ahead and give that a try. The opposite of 0 is 0. The opposite of 4 is -4. The opposite of -3 is 3. And the opposite of -7 is 7. And I'm going to add that to row 2, which is 0, 5, -2, -7. 0 plus 0 is 0. -4 plus 5 is 1. And that 1 is going to replace this 5. 3 plus -2 is 1. And 7 plus -7 is 0. So then what we're going to do is we're going to take this row and we're going to replace row 2 with this new row. I'll do that now. So next, I am going to try to make this 4 right here a 0. So I bet you're thinking you know what to do to make this 4 a 0. What if we take row 2, we multiply it by -4, and then we add it to row 3, and then that gives me my new row 3. So let's come over here and do that. -4 times row 2. -4 times 0 is 0. -4 times 1 is -4. -4 times 1 is -4. And -4 times 0 is 0. Ooh, that looks terrible. All right, and then we're going to add that to row 3, which is 0, 4, -3, and -7. So 0 plus 0 is 0. -4 plus 4 is 0. -4 plus -3 is -7, and 0 plus -7 is -7. So we're going to take row 3 and replace it with this new row. Now we're so close to being done because we have a 1 and a 1, and we need to make that -7 a 1. And then if we look below the diagonal, these are all zeros, which is great. So we're almost to row echelon form. We can just simply multiply this row because of the zeros. We can multiply it by -1/7. So let's do that. We're going to take row 3 and we're just going to multiply it by -1/7. And that's going to give us our new row 3. So -1/7 times 0 is 0. And -1/7 times 0 is 0. And -1/7 times -7, two negatives make a positive, and we get 1. And -1/7 times -7 is going to give us 1. So we're going to take this third row and replace it with our new row. So now you can see that I've reached my goal. I have 1s going diagonal, and you can see I have zeros all below. And so this is called row echelon form. And the reason why this matrix is so cool is because 0x, 0y, 1z. So it's telling me that z is equal to 1. And then 0x, 1y plus 1z is equal to 0. And then the last equation, it's telling me that 1x plus -y, or subtract y, and then here's 1z plus z is equal to 4. And this is a triangular system of equations, which means I can take z, plug it in, and find y. So that means that y is also going to be 1. So if I take z and plug in 1, subtract it over here, actually -1. So y equals -1. And then you could take z and y, plug them in here. So now I have x subtract -1, which is +1, plus z, which is 1, is equal to 4. And so x is equal to 2. So therefore, we've got z is 1, y is -1, and x is 2. So my order triple is x, y, and z. And this is row echelon form. And that's it.